Okay, so 4.1, we start out just with notation. This is just to say these are all the same. Dy dx does not indicate that y is necessarily a function of x. It does imply there's a relationship between x and y. F prime of x, this having f of x in it, and this having f of x in it, all of those imply that it's a function of x. So this capital D sub x is a little unusual. Most people do not do this. Sometimes people do this because it's just sometimes easier to not say y equals blah, dy dx equals. Just start out with d dx of, and then put whatever the function is in there. So you just kind of skip a step in writing. That's usually a more advanced math situation that you would want to do that, but you can do that. And then dy dx, if I pulled this y over there, it's kind of the same as this, except replacing f of x and y. This is very common. And then there's f prime of x. And actually, I frequently will just write y prime. If y is a function of x, then the prime is clear. It's clear that it's the slope with respect to x. So like whatever's on the bottom slope is rise over run, right? So whatever's on the top, that variable, is the rise part. That's the vertical, and that's the horizontal. And you can treat them in the opposite way. It's just that you're considering the slope of the line go in a different direction then. So this is just saying, I'm looking at the slope as though y is rise and x is run. And the d, you may have seen in other courses, delta, t, delta something, and it always means change in. This is basically change in y compared with change in x. It's just that we're letting it get arbitrarily small in both directions. So it's still a ratio, it's still comparative, but we're not far enough apart to separate y. So it's really a comparative rate. How fast does y change as x changes? Okay, so that was a lot that hopefully kind of gave you hooks to hang things on. So these first two, we're still using the definition. So let me, well, I can remember that one, so I'll just snag this one. So the first one, we've got f of x is k. Okay, so, let me pause this to get my pen working here. Okay, so basically the most irritating thing happened. I had stopped recording to try to figure out what was going on with my pen, and then I did the entire video, and then came back and it was like, could not record. So out of frustration, then I waited to come back to it, and now it's 1:30 in the morning, so that's awesome for everyone. And I'm trying to make sure that it is recording now, so I'm going to complete it and see what happens. Okay, this seems to be working okay, so I'm going to try to get back to what I was doing. Not at the end, but at the beginning. Okay, so the first one was actually f of x equals k. So we're using the definition of a derivative. The limit as h approaches 0 of f of x plus h minus f of x over h. Sorry about that. This is the limit as h approaches 0 of k minus k over h is the limit as h approaches 0 of 0 over h. If h is approaching 0, it's not 0, so 0 over anything other than 0 is 0. But this, here's a graph of f of x equal to k, so suppose this is k right here, then the horizontal line going like that is f of x equal k. So of course the slope everywhere is 0 because it's just horizontal all the time. The next thing to look at is this f of x equals x squared. So we have the limit as h approaches 0 of x plus h squared minus x squared over h. Now I'm going to FOIL this, so I'm going to get x squared plus xh plus h squared minus x squared over h. So I'm going to factor out an h, plug in 0 for h, and I get 2x. Now, I want to make a point kind of about x to the n. So we would start out with limit as h approaches 0, x plus h to the n minus x to the n over h, right? But let's talk about x plus h to the n. Pascal's triangle, which is really combinations, when you have, like when I FOIL this, let's say it's squared, and I FOIL it, and I have that 2xh plus h squared. Basically, when I FOILed it, this appeared twice. It happened in the outside and it happened in the inside, and that's why I have two of them. If I have x plus h cubed instead, then I get x cubed plus 3x squared h plus 3x h squared plus h cubed. Now each time I've got, when I put these all together, basically each term up here in the product would have been somebody from here times somebody from here times somebody from here. And it just all kind of gets, spread out, and then you combine the like terms. But in the one case, I got all three x's. I could have gotten xxh, that's an x squared h. I could have gotten xhx, that's an x squared h. Or I could have gotten, well, now I don't remember which one I've already said. I could have these two x's and this h, or I could have these two x's and this h, or I could have these two x's and this h. So there are three different ways I can pick two x's and one h. Similarly, there are three different ways I can choose one x and two h's. And there's only one way to pick all three h's. I have to pick all three of the h's. So generally speaking, when you have n of these, so I have x plus h, x plus h, x plus h, n times. So if every piece will have n letters, so let's say that I have x to the 5th, h to the n minus 5, because I've got to have n pieces total. The question is, how many ways could I have picked where my 5 x's came from? So there's, let's say, 20 of these in here. So I could have gotten this x, this x, this x, this x, this, like that. So out of these n binomials, how many different ways could I have chosen my 5 x's? That's what these coefficients really are. They're really, out of all these pieces, how many ways could I have chosen these x's? So if it's x cubed, then it's how many ways could I have chosen 3. So this notation means if I have n things, how many different ways can I choose 5 of them? And here 3. So that's what they are. But there's a way to list them out using Pascal's triangle. So you start out with 1, because if you have x plus h to the 0, there's only one way to choose no one. So this is just 1. Then you take 1 plus nothing is 1, 1 plus nothing is 1. You're always coming out for a triangle. So I have x plus h to the 1. Then I'm just going to have x plus h. There was one way to pick the x and one way to pick the h. Period. So it's just x plus h. Then 1, again, because 1 plus nothing is 1. 1 plus 1 is 2. 1 plus nothing is 1. There's one way to choose both x's. You choose both x's. x squared. There's two ways to choose the xh. You can choose the x from the first one and h from the second, or h from the first and x from the second. So 2xh plus, there's one way to choose h from both of them. It's the choose h from both of them way. So you keep going with this triangle, and this gives you the coefficients for each of these powers. So the first row is the 0th power, so you get 1. To the first power, you get coefficients of 1, 1. Second, it's 1, 2, 1. The third, 1 plus nothing is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus nothing is 1. This is the coefficients of the one that we already looked at and kind of counted out the ways we could do them. 4, 1 plus nothing is 1, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus nothing is 1, and it keeps going like this. We're only going to end up caring about these first two terms. So just note that this one's always going to be 1 added to nothing, so it's just always going to be 1. This one's always going to be 1 added to the guy next to him, so it's counting up. And it's on the same row, so the 0th power, there's nothing. On the first power, it's 1. Second power, it's 2. Third power, it's 3. Fourth power, it's 4, like that. Because it's the how many ways could I have chosen one h, basically. So if I have n choices and I have to pick an h, there are n options. So this ends up being n for all of them. Okay, so x plus h to the n equals x to the n, because there's one way to do that, plus there are n ways to choose one h, which means I have n minus 1 x's. And then there are n choose 2, whatever this happens to be, x to the n minus 2, h squared, and then plus down to h to the n. When I subtract x to the n, that goes away. So I have n x to the n minus 1h plus n choose 2, x to the n minus 2, h squared plus down to h to the n. So the limit as h approaches 0 of x plus h to the n minus x to the n, so this is the function we're looking at, x to the n, over h equals the limit as h goes to 0 of this. Now the reason I'm putting these dots and I'm not worried about it is because once I factor out h, the point is that all of these will still have an h in them. So I'll have n x to the n minus 1 plus so when I plug in h is 0, this is all gone. So having done that now, with total confidence, we can believe this formula for a positive integer n. You're going to have to take me on faith that this works for all real numbers n. We need future things to kind of prove that one, so you just kind of have to accept this for now. So if it's a constant, it's just 0 for what we talked about before. There's that horizontal line. If it's a power of x, bring down that power and drop the degree by 1. Okay, so for that first one, remember that that's just another way of writing derivative of y with respect to x. So I bring down the 5, x to the 5 minus 1, done. B, dy dt, you could think of it this way. You could think of it as this is a line, so the slope is the same everywhere. We know the derivative is the slope, but every single place on this function, the slope is 1 because it's a line. Or you can realize that t is t to the 1, so bring down the 1, t to the 1 minus 1 is t to the 0 is 1. Okay? C, you have to recall, we need to definitely keep these in mind. There are two power rules that people always forget. One of them is that a to the negative n is 1 over a to the n. So the negative powers just change position on the fraction. If you had a to the negative n in the bottom, you'd move it to the top and make it positive. Also, a to the m over n is the nth root of a to the m, or the nth root of a to the m. So in this case, 1 over x squared, y equals x to the negative 2, so in the denominator, so dy dx, negative 2, x to the negative 2 minus 1, and because I like to give things back the way they were given to me, I would move that to the bottom. Okay, now let's look at these. So this is one of those times where you're given derivative of with it in the parentheses. Because it's not complicated, I'm just going to kind of say equals, and I'm not going to rewrite it. If there was anything to do inside here, then I'd write dx of and fix it. You can't just go off to the side and write this function because this function's not been named. I mean, you can in your own notes, but it's not precise, I guess. Okay, so 2/3 x to the 2/3 minus 1. So 2/3 x to the minus 1/3. You can put that in the denominator and make it 1/3 if you want. I wouldn't write it as a cube root because this was not written as a root. So this one, y equals, if there's no number there, it's a square root. So it's an implied 2. If there's no number there, it's an implied 1 because z is just z to the 1. So it's z to the 1/2. So dy dz is 1/2, z to the 1/2 minus 1 is 1/2, z to the minus 1/2 is 1 over 2z to the 1/2, 1 over 2 root z, which I would do to make it match. Okay, so here we get the, if you have a constant outside it, you remember all the rules about limits were all exactly what you wanted them to be. A constant times the limit is the limit times the constant of the product is the limit of the product is the product of the limits, the limit of the sum is the sum of the limits, and all those things that you would kind of hope for. Because a derivative is a limit, those all still apply. So if I have a constant hanging out, it just continues to hang out. Okay, this had indeed stopped recording again, so here I go again with this. So on this first one, I leave the 3, bring the 4 down, and then for this one, the negative 3/5 just hangs on. Bring down the 11. And that one's done. But then, as I said, the sum and difference rules also apply. So if I have multiple pieces, I just take the derivative everywhere. Okay, so this first one, leave the 3 outside, bring the other 3 down. So the 3 minus 1 minus 2x to the 2 minus 1 minus. So on this one, again, you could treat this as x to the 1, bring the 1 down, x to the 1 minus 1. Or you could just recognize that it's a line. And so x to the 0 would be 1, so you'd end up just multiplying by 1. But you can also just say the slope of this line is negative 1/12. This one, we have the negative 2 hanging on the outside, 2.5x to the 2.5 minus 1, plus, leave the 8 outside, bring down the 5, 5 minus 1. So negative 5, x to the 1.5, plus 40, x to the 4th. For this last one, I need to rewrite that part. So y equals negative 100, x to the 1/2. If there's nothing there, it's a 1. If there's nothing there, it's a 2. So 1/2. Okay, so dy dx equals, leave the negative 100, 1/2 x to the 1/2 minus 1 minus 11 times 2/3 x to the 2/3 minus 1 so this together is minus 50 x to the negative 1/2 minus 22/3 x to the minus 1/3. So because this one was given to me as a fractional power and this one was as a root, I'm going to go ahead and move this one. The negative puts it in the bottom, root x. And then probably just would leave that. You can put that in the bottom with the 3 if you want to and just make it a positive 1/3. Okay, so I'm going to rewrite f of t. I get my computer back situated. I'm now saving periodically, so I don't have to do this over. So f of t equals 6t to the negative 1, because the power's not there, so it's assumed to be 1, but it's in the denominator, so that's negative, plus 5t to the negative 2. So f prime is 6 times negative 1, t to the negative 1 minus 1, plus 5 times negative 2t to the negative 2 minus 1. So minus 6t to the negative 2 minus 10t to the negative 3. And then of course I would rewrite it to match that. So negative 6t goes to the bottom, that squared becomes positive. 10 over 10 cubed, that 3 becomes positive when you move it to the denominator. Okay, so this one, it's not named, it's not called y, so I can't just suddenly write this, and say I'm going to take the derivative. So I'm going to have to leave this on here while I rewrite it, and then I'm just going to remove that when I take the derivative, because this says take the derivative. So I'm noting I still need to take the derivative, I'm just rewriting it. Once I take the derivative, I'll stop writing that. So this is 8x to the, it's negative because it's in the denominator. 1 is the imagined power there because there's not one written, and then 4 is there. So 1/4 minus 3, that 3. X to the 1/3. So 8 times negative 1/4 x to the negative 1/4 minus 1 minus 3 times 1/3. Sorry, that was negative 1/3. Negative 1/3 x to the minus 1/3 minus 1. So I said before that this was negative because it was in the denominator, and then I just didn't write it down. So that should have been negative 1/3 all along. 8 times negative 1/4 is negative 2. X to the negative 5/4, common denominator between 1 and 1/4. Minus 3 times minus 1/3 is plus 1. X to the negative 4/3. I'm going to give it back the way it was given to me. So the negative 2 will stay on top because it's not taken to a power. And then down here I'll have an x to the 5/4. So there's definitely going to be a root. And this one's just 1, and there's a root. This one is x to the 5/4, so 5/4. This one is 4/3, so 4/3. Okay, so I'm going to read this to you now because I'm going to just remember it. Of course, I've already done it a couple of times now, but we're going to talk about when the tangent line is horizontal. So that's the question that goes with this second equation. On the first one, it asks for f prime of 3. So the first thing I'm going to do is find f prime of x. Bring down the 3, x to the 3 minus 1, minus 8 times. Bring down the 2, x to the 2 minus 1, equals 3x squared minus 16x. So if I want to know what that is when I plug in, or what f prime of 3 is, I just plug it in. Once I've written it this way, the derivative is a function of x, so I can just plug stuff in. So 3 times 3 squared minus 16 times 3 is 3 times 9 minus 48. So negative 21. Now this one was asking when is the tangent horizontal? All that I know about the tangent line is that its slope is the derivative. So I would have to ask myself, what does it mean to be horizontal? Well, it means that you're equal to a constant, but it also means your derivative is 0. So if it's just in one particular place, then it's not constant. It's just at that moment there's a turnaround point or a wiggle point or something that makes the tangent horizontal there. But we're always, for horizontal tangents, going to want to find when the derivative is 0. So first I need to take it. So minus 2x to the 2 minus 1. This is a linear piece, so the slope is the slope. Again, you can write that as a 1, do the 1 minus 1, but you don't have to. The derivative of a constant is 0. So there's the derivative. So to find all places where the tangent line is horizontal, you set the derivative equal to 0. And that's the only place it happens because the derivative was a line course, the function is quadratic, so it's a parabola, so it only has one place with a horizontal tangent, which is, in this case, the max, because it opens down. It could be the max or the min for a quadratic. Okay, so here's our last thing. When I do this in class, I kind of do it two different ways. There's the in terms of Q, which is implied here by the R of Q, and there's the in terms of P, which might be your natural inclination because you are given Q in terms of P. The only problem with doing it that way is then when you are plugging in the units, because you need P to plug in when it's in terms of P, you have to take this 1,000, plug it in there, solve for P. So you have to solve for P 3 different times. Whereas if I solve for P the first time, then I get it in terms of Q, which you'll see in a minute, and then you can just plug them straight in. When the revenue is increasing, whether you're on quantity or price, if it's at the same level of production, there's a certain price that goes with a certain level of production, the revenue's slope will be positive or negative or zero. But the positive and negative will be different values from each other because one of them is in terms of price, so that it's the quote-unquote X value, the horizontal value is price, and the other one is in terms of quantity, so it's scaled differently, like 100-fold, for example. So I'm going to, for the sake of the video, just solve it for Q. So I want R of Q. Revenue is how many did I sell, how much did I get for each one. But I need to have then something to replace P with that has Q's in it. Right now I have the opposite, so I'm going to come over here and say, well, then Q minus 5,000 is negative 100p. So negative Q over 100 plus 50, because negative over a negative, equals P. So now I've just substituted for P. So this is negative Q squared over 100 plus 50Q. That's revenue. But I don't want revenue, I want marginal revenue. Marginal means take the derivative. So I need to take the derivative. I'm just going to leave the 100 on the bottom, just as I would leave something on the outside. It's a number. Negative. Bring down the 2. Q to the 2 minus 1. Plus, this is a line, so I can just take the slope. If it's just times Q, it's just the slope. So that's a 1 to the 1 minus 1 gives you to the 0. I'm just going to reduce that. So negative Q over 50 plus 50. So the 2 over 100 made the 50, and the 2 minus 1 makes it just Q. Okay, so first for part A, I want R prime, of 1,000. So at this point, at the level of production of 1,000, the revenue is increasing because it has a positive slope. Positive slope means going up. And plug in 2,500. The derivative here is 0. That means that it's a horizontal tangent. It's either a max or a min at a production level of 2,500. So again, if I had done R in terms of P and taken the derivative, and then plugged in 25 for P, that's the same as 2500 being Q, then I would have gotten the zero derivative there as well. And then C, R prime of 3000. At this point, my derivative is negative. So at a production level of 3000, if I continue making more, making more items, then I'm actually going to have less revenue, which doesn't bode well for my profit at all. So this is a maximum here. There's a maximum at this 25 price, 2500 quantity thing. So that is it for the upteenth time for 4.1.